Functions, Part 1. In this chapter, we will learn about functions, inverse and composite functions, solution of equations, logarithmic and exponential functions, and transformation of graphs. This video will cover only on the first subtopic. At the end of this video, you should be able to determine whether a relation represents a function and find the value of a function. Relation. A relation is a set of ordered pairs. The set consisting of the first components of each ordered pair is called the domain, and the set consisting of the second components of each ordered pair is called the range. For example, consider the given set of ordered pairs W. The first numbers in each pair are the first four natural numbers, while the second number are 120, 100, 150, and 130. The domain of W is given by set D, and the range of W is given by set R. Note that each value in the domain D is also known as input value, and each value in the range R is also known as an output value. Functions. A function is a relation in which no two ordered pairs have the same first element. A function associates each element in its domain with one and only one element in its range. Look at the given example. Determine whether the following relations are functions. Solution. Set A is a function because all the first elements are different. Although set B contains two ordered pairs with the same second element, set B is also a function because all the first elements are different. This means that the second element does not need to be unique. And set C is not a function because the first element 1 is repeated. This figure compares relations that are functions and not functions. The relationship shown in figure A is a function because each input is associated with a single output. Note that input Q and R both give output N. The relationship shown in figure B is also a function. In this case, each input is associated with a single output. However, the relationship in figure C is not a function because input Q is associated with two different outputs. Therefore, a function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. The input values make up the domain, and the output values make up the range. Function notation. The notation y equals to f of x defines a function named f. This is read as y is a function of x. The letter x represents the input value or independent variable. and the letter y or f of x represents the output value or dependent variable. Finding input and output values of a function. When we know an input value and want to determine the corresponding output value for a function, we evaluate the function. Evaluating will always produce one result because each input value of a function corresponds to exactly one output value. When we know an output value and want to determine the input values that would produce that output value, we set the output equal to the function's formula and solve for the input. Solving can produce more than one solution because different input values can produce the same output value. Example: evaluate the function f of x equals to x squared plus 3x minus 4 at the given values. Solution: in order to solve this equation, we need to replace the x in the function with each specified value. Solution A: because the input value is a number 2, we can use simple algebra to simplify. Therefore, f of 2 is equals to 6. Solution B: the input value is a letter, so we cannot simplify the answer any further. Therefore, f of A is equals to a squared plus 3a minus 4. Solution C: with the input value of a plus h, we must use the distributive property. Therefore, f of a plus h is given as in the slide. In the previous example, the input value are known and we need to determine the corresponding output value for the function. Now, in this example, we are given the output value and we need to find the input values for the given function. To solve for h of p equals to 3, first, substitute h of p with the original function p squared plus 2p. Then, subtract 3 from each side. This will give us a quadratic equation. Factorize the quadratic equation. Set each factor equals to 0 and solve for p in each case. This will give us two solutions, p equals to -3 and p equals to 1. We can also verify this by graphing. From the graph, the value of h is equals to 3 when p is equals to 1 and p is equals to -3. Try the given exercise.